Hi everybody! Today I will be talking about the structure and properties of different types of molecules and compounds. When atoms combine chemically, they form bonds, such as maybe this bond over here, shown as a line. There are many types of bonds, but in this video I will talk only about two of them, covalent bonds and ionic bonds. So let's start off with covalent bonds written over here. What are covalent bonds? Covalent bonds are bonds that form between two atoms when they share electrons. So atoms sharing electrons. So I will not go into why they create these bonds just yet because that will be discussed in future videos. But for now, I will introduce to you the three types of covalent bonds that are possible. When two atoms share one electron, they form a single bond. So in this image, because the atomic number of hydrogen is 1, hydrogen will have one electron to spare. So both hydrogens will each contribute one electron to this single bond, and the line simply kind of connects these two electrons together. So one line represents a pair of electrons. So now let's look at a double bond. A double bond forms when each atom contributes 2 electrons to the bond. So in this image, this oxygen will contribute 2 electrons, and this oxygen will contribute 2 electrons. And as a result, you have 2 lines because there are 2 pairs of electrons being shared. And if you were wondering, these electrons over here are actually called lone pairs, and they are not involved in the bonding process, so they are excluded from the bonds. Now let's look at a triple bond. A triple bond, such as the one between 2 nitrogens, involves each nitrogen sharing 3 electrons each, as shown here. And remember, these are non-bonding electrons. So covalent bonds usually form between 2 nonmetals, such as 2 hydrogens, 2 oxygens, 2 nitrogens, and even an O and an H, such as in H2O or water. We call molecules with covalent bonds covalent molecules or even covalent compounds. And something else you should know about covalent molecules / compounds is that they are electrically neutral, meaning that the overall charge of this molecule right here will be 0. So let's get on to our next topic immediately. So when we write out molecules or compounds, the most common way is to write their molecular formula. You have already seen me done this. I wrote H2O, which means water. So another example of a molecular formula is this right here, CH4O. So this tells me that there is one carbon atom, since the 1 is invisible, but it is implied that there is 1 there. But we don't write that, so let's just erase that. So from this formula, we can imply that there are 1 carbon atom, 4 hydrogen atoms, and 1 oxygen atom. So how do you know what order to put the atoms in? Well, you kind of just figure it out with experience, so don't worry about that for now. But if you really want to know, generally we put the atom with the lower atomic number first. So in H2O, H comes first because H has a lower atomic number, while O has a greater atomic number of 8 compared to 1. Now there are a few exceptions. For example, H always comes after C, and H always comes after N. So in our example here, H came after C because it is an exception as said over here, and O comes after C because O has a greater atomic number than C. Another way to represent chemicals is by using structural formulas. This is where you draw out the chemicals with all the covalent bonds. So in this image, we have CH4O. So our 4 H's are over here, our C is over here, and our O is over here. So let me undo that. So you will learn how to draw these structural formulas in the future, so don't worry about them for now. Last but not least, we have a condensed structural formula. It's basically the same thing as a molecular formula, but the atoms are written out so that the links are easier to see, or the structure is easier to see from the formula. So for example, CH3OH is easier to see than CH4O when it comes to the structure, because we can clearly see CH3 over here, and we can clearly see OH over here, while in our original molecular formula, you can't really tell that there's an H here and there are 3 H's here, because they're all clumped up together, because all the hydrogens are counted and added up. On the other hand, in our condensed structural formula, they are separated to make drawing the structure easier. So let's talk about the second kind of bonding. These bonds are called ionic bonds. Before we talk about ionic bonds, we need to talk about ions. Ions form when an atom loses or gains one or more electrons. They do this to be stable, which will be explained in later videos. So let's draw an atom. So let's just say this atom had 6 protons and, of course, 6 neutrons for its nucleus, and surrounding it we have, 6 electrons in total. So this is an atom because it is electrically neutral. 6 electrons and 6 protons cancel out in charges because positive 6 plus negative 6 is 0. So the original number of protons and electrons are equal in an atom. But when you lose an electron, there will be more protons than electrons. So if I lose 1 electron, then I will have 5 electrons instead of 6 electrons. So the atom overall becomes positively charged because positive 6 minus 5 is equal to positive 1. So if you think about it, if you're losing an electron, you are becoming less negative or more positive, which is why the overall charge of this ion is now positive. So when an atom loses or gains an electron, we call it an ion. But there are specific types of ions. A positively charged ion is called a cation. You can memorize this by thinking of cations as positively charged. So let me write that. So positively charged. And where the reference comes in is that it's a cat and it has a paw, and that it's positively charged. So that's a good way to memorize it, because you can associate cat to a paw, which is positively charged. Now let's talk about what happens when an atom gains an electron. So instead of having 5 electrons, maybe this will have 7 electrons. So now that that's happened, the overall charge of this ion is going to be negative because you're gaining electric charge, or you're gaining electrons, so you're becoming more negative. So let's calculate the charge. So positive 6 minus 7 is equal to negative 1. So these negatively charged ions are called anions. And how do we memorize this? Well, think of it this way. You can memorize anions by saying that anions are anti and against everything, which connotes a negative connotation, hence why anions are negative. So now that we got down the topic of ions. Now let's talk about ionic bonds. So ionic bonds form between cations and anions because they are attracted to each other, since oppositely charged ions will attract since they have opposite charges, right? So for example, sodium chloride NaCl is composed of Na plus and Cl minus, so the sodium cation and the chloride anion. We call compounds that contain ionic bonds ionic compounds or salts. Just like a covalent compound or molecule, salts are electrically neutral overall because the negatively charged anions and the positively charged cations cancel out in charge, making the salt overall neutral. So ionic bonds usually form between a metal and a nonmetal. For example, in the case of sodium chloride, sodium is the metal and chloride is the nonmetal. Now, unlike covalent compounds, ionic compounds contain a crystal structure of cations and anions all combined in an orderly fashion. So in this example, sodium chloride is arranged in a crystal structure where we have alternating cases of sodiums and chlorides. And the reason why sodiums and chloride ions alternate is because opposite charges attract. So naturally, this positively charged sodium, for example, will want to be next to negatively charged chloride anions, for example, these three, and that's what makes these compounds stable. So we don't call ionic compounds ionic molecules because molecules, although technically correct since a molecule is just two or more atoms, molecules usually refer to chemicals with covalent bonds like H2O. But on the other hand, we usually refer to ionic compounds as compounds and not molecules. So just keep a note on that. So don't worry about naming ionic compounds like sodium chloride just yet, but we need to cover how to write the chemical formulas for ions. So in this next slide, I will show you that. So if chlorine gains an electron, we denote it as Cl-, since it has an overall charge of -1 due to the extra electron. We don't put the 1 there because it is implied when we write minus. What if oxygen gained 2 electrons? Then it would be O2- or O-2, but I prefer the first one. The order of the negative doesn't really matter. So what if calcium lost 2 electrons, as shown here, when calcium breaks up into 2 electrons and calcium 2+. So it would be calcium 2+ because there are 2 more protons than electrons once you lose 2 electrons. So you would have an excess of a +2 charge, since you have 2 more protons now that you removed 2 electrons. So now let's talk about a special type of ion. It's called a polyatomic ion. It is when a molecule has an excess of protons, aka a positive charge, or an excess of electrons, aka a negative charge. So in other words, it is a molecule or a compound that has a charge. For example, NO2 is a molecule because it is neutrally charged, and it has, equal numbers of protons and electrons in it. But NO2- is a polyatomic ion, since NO2- has 1 more electron than it does protons, and thus a -1 charge. But that doesn't necessarily mean NO2- was formed by adding 1 electron to NO2, as we did with Cl, for example. Sometimes the process is more complicated. For example, NH3 will convert to NO2 through a series of processes. Weird, right? Well, sometimes chemistry just blows our minds, honestly. So now let's get back to polyatomic ions. So just like Cl-, NO2- can also form ionic compounds or salts. So for example, we have the salt NaCl. We can also have the salt NaNO2. I don't know why I didn't put the 2 there. I might have erased it. So yeah, we'll talk about naming ions and molecular compounds in the next few videos. Thank you for watching. Have a nice day.